Hey guys, Mr. Backberg here. This is part 1 of lesson 7.4. We've got two objectives for this video. We are going to recognize partial fraction decomposition of rational expressions, and we're going to find partial fraction decompositions of rational expressions. When we're doing partial fraction decomposition, our goal is to take a rational expression and rewrite it as a sum of two or more simpler, easier to work with rational expressions. So in our picture, we've got this rational expression on the left-hand side, x plus 7 over x squared minus x minus 6, and its partial fraction breakdown on the right-hand side. Each one of these individual fractions is called a partial fraction, and the entire sum on the right-hand side is called our partial fraction decomposition. A couple of steps we go through when we're finding a partial fraction decomposition. First thing we want to do is factor out the denominator as much as we can, and then we'll use those factors to split up our fractions. If we have a repeated factor, then we need to make sure we're including every power of that repeated factor. So here's that example that showed up at the very beginning of the notes, x plus 7 over x squared minus x minus 6, and we're going to look at how we find the partial fraction decomposition of this rational expression. And what we want to do first is we want to look at that denominator and see if we can factor it out. So we're going to end up with two sets of parentheses on the bottom of our fraction. In order to get that x squared, we'll need an x and another x. We need to multiply to negative 6 but add up to negative 1. So I think we will need a negative 3 and a positive 2. So now we're going to start splitting up this fraction. And what we're going to do is we're going to make a separate fraction for each of these factors. So x minus 3 is going to go on the bottom of one of our fractions, and x plus 2 is going to go on the bottom of the other fraction. Now what we need to figure out is what's going to go on top of each one of our fractions. Now these are linear factors. They have a power of 1 on the x. So when we write out the stuff on top, we have to drop the power by 1. So if we have a linear factor here, we drop the power by 1. It just becomes a plain constant number on top with no x's. So we're going to represent that with an a value. And a just stands for some number. On our second one, again, since we have a linear factor, we're going to drop the power 1 and get a constant with no x's on top. We've already used a, so let's call this one b. Now what we're going to do is go through and solve to figure out what these a and b values are. And I'm going to slide this stuff over just so I have a little bit more room to work. What we want to do is I want to look at this fraction on the left-hand side, and I want to make it something that's no longer a fraction. So right now we're dividing by these factors, x minus 3 and x plus 2. So in order to get rid of those so it's no longer a fraction, we're going to multiply both sides by x minus 3 and by x plus 2. So those things will cancel out over there. Whatever we do to the left side, we also have to do to the right side. So we'll take x minus 3 and x plus 2 and multiply that stuff on the right-hand side as well. Now on the left-hand side, all we've got left over is that x plus 7. On the right-hand side, when we do this multiplication, we're going to have to do a little bit of distributive property. First I'm going to do is take both of these things and distribute it to our first fraction. Now we should notice that when we do this multiplication, we'll end up with an x minus 3 on the top of our fraction and also an x minus 3 on the bottom of our fraction. So that stuff is going to cancel out. So all we're going to have left over in this first fraction is our a, and then we'll have that x plus 2 factor left over as well because that did not cancel out. Now if we take this stuff and distribute it to our second fraction, this time we'll have an x plus 2 on top and an x plus 2 on bottom. So those things will cancel out. So we'll have our b value left over. We'll also have that x minus 3 factor left over. Now I'm going to do a little bit of distributive property with these things on the right hand side. So we get x plus 7 equals ax plus 2a plus bx minus 3b. Now what I'm going to focus on first as far as solving this is I want to look at the things that have x's on them, and I'm going to start building a new equation based on those things that do have x's. So I'm looking at this x on the left hand side, so we've got x equals. As far as things that have x's on the right hand side, we've got ax and we've also got a plus bx. That's going to be our first equation, and really what we're setting up is a system of equations that we can go through and solve for these a and b coefficients. Now the other thing that I'm looking at is we've got this constant of 7, and as far as constant stuff on the right hand side, we've got this 2a and this minus 3b. So I'm going to set up a separate equation using all of that information. Now there's a little bit of a problem with our setup right now. In that first equation, all we've got is variables. We don't have any numbers at all. So in order to fix that, what I'm going to do is take that equation, and since there's an x on the left-hand side with no number in front of it, I'm just going to divide everything by x. So x divided by itself, well, if we take a number and divide it by itself, we get 1. And then if we do this division on the right-hand side, those x's will end up canceling out, so we'll just get a plus b. Then we've got our other equation, 7 equals 2a minus 3b. Now we've got a whole lot of options as far as solving this system. We could do substitution or we could do elimination. I think I'm going to use elimination. So what I'm going to do is take this top equation times negative 2. So then we get negative 2 equals negative 2a minus 2b. And then adding these two equations together right here, we get 5 equals, well, those a's cancel out, negative 5b. Then if we divide both sides by negative 5, we end up with b equals negative 1. Then if we back substitute to find our a value, I'm going to use, let me highlight this equation right here, 1 equals a plus b. If we plug in that negative 1 for our b value, then our equation says 1 equals a plus negative 1. And adding that 1 over to the other side, we get a equals 2. Now we're not quite done yet, because now what we need to do with these a and b values is go all the way back up to the top where we split up this partial fraction stuff where we had a over x minus 3 and b over x plus 2. Well, we know what those a and b values are now, so we're going to fill those in. So our a value goes on top of that first fraction, 2 over x minus 3, plus our b value goes on the top of that second fraction, and we've got x plus 2 on the bottom there. So this right here is our partial fraction decomposition. Looking at our next example, we've got x plus 8 over x squared plus 6x plus 8. Just like we did on the last one, the first thing I'm going to do with this is factor out the denominator. So we've got an x squared, so we're going to need an x and another x. We need to multiply to 8, but add up to 6. I'm thinking plus 2 and plus 4. Now, if we look at splitting this up, we'll go x plus 2 on the bottom of one fraction, x plus 4 on the bottom of the other fraction. These are each linear factors, so the top will be constants. We'll call the first one a, the second one b. Then we will do our multiplying by the denominator over here. So we're going to multiply by x plus 2 and by x plus 4 to get those things to cancel out. We're also going to have to multiply by those on the right-hand side, so x plus 2 and x plus 4. And this turns into distributive property. So taking both of those things times the first fraction, those x plus 2's cancel out. So we'll have the a left over and the x plus 4 left over. If we distribute to our second fraction, this time the x plus 4's cancel out. So we've got the b and the x plus 2. Left-hand side, we've got x plus 8. Taking care of our distributive property on the right-hand side, we get ax plus 4a plus bx plus 2b. Now I'm looking at the things that have x's, so we got x, ax, and bx. We're going to set up an equation with that. So x equals ax plus bx. And we need some numbers in there, so I'm going to divide everything by x. So x divided by x is 1 equals, here those x's will cancel out, so we'll get a, and these x's will cancel out, so we'll get plus b. If we look at our constants, we've got 8, 4a, and 2b, so 8 equals 4a plus 2b. And now we're solving for each of our variables. I am going to multiply the top equation by negative 2, so we get negative 2 equals negative 2a minus 2b. Adding these two blue equations together, those two b's cancel each other out. We get 6 equals 2a, so our a value is 3. If we take that a value of 3 and I'm going to plug it into this equation right here, so 1 equals 3 plus b, we end up with a b value of negative 2. Then looking at our fractions that we started with up at the very top, our a value is 3, so that first fraction is 3 over x plus 2, plus our b value we just said was negative 2 over that x plus 4, and here is our partial fraction decomposition. Sometimes when we end up doing the factoring portion, we end up with a factor that repeats itself. So if we're looking on the bottom of this fraction, with having this x plus 2 to the 4th power, really that's like having x plus 2, another x plus 2, another x plus 2, and one more x plus 2. Okay, we'd have 4 x plus 2s. When those factors repeat themselves, we have a special way of dealing with them. And what we're going to do when we set up our fractions is we need to build up to this 4th power. So our first fraction is going to have just a plain x plus 2 on it. When we set up that second fraction, we're going to go x plus 2 squared. So we've gone from a first powered factor to a second power factor, and we're just going to keep building our way up to this 4th power. So now on our third fraction, we've got x plus 2 to the 3rd power, plus on our last fraction, we've got x plus 2 to the 4th power. So now we've accounted for all of those powers of this factor. Now to figure out the stuff that's on top, again we look at the x. We look at the power on the x. These are all first powered x's. Even though there's like a 3rd power on this one, the x itself only has a first power on it. So when we're putting things on top, we drop the power by 1. So since these are all linear factors, on top of these fractions, we're going to have constants with no x's. So we've got a, b, c, and d. Now we're not going to go through and solve this one. We're just setting this one up. In this example, again, we're just going to set it up. We're not actually going to solve it. But now we're looking at it, and one of those factors on bottom has a power on the x. So if we were to look at breaking this up, we'd go x underneath the first fraction, and since that's a first powered x, we'd just put a plain constant a on the top. With this second one, when we set this up, though, we've got a quadratic. So if we look at dropping the power 1 on there, there still needs to be an x involved. So we're going to go bx, but then we need to get down to this constant, so we're going to throw a plus c on the end there. So if we have a linear factor on bottom, we have a constant term on top. If we have a quadratic factor on bottom, we have a linear first powered x and a constant on top of that fraction. In this example, we've got a repeated quadratic factor on the bottom. We are going to set up and solve this one. So we've got 8x cubed plus 13x all over x squared plus 2 all squared. So when we look at setting up these fractions, since we've got this repeated factor, remember the first fraction gets x squared plus 2 with no power on it, plus the second fraction gets the x squared plus 2 with that squared power on there. Now if we look at our x, this is a quadratic, so on top of this one we're going to go ax plus b because we need something linear with a constant. On this second one, again, we've got an x squared, so we need cx plus d. So now we've got 4 variables that we're going to be solving for. We're still going to treat this exactly the same as we were doing before. In order to get rid of that denominator, we're going to multiply both sides by x squared plus 2 squared to get that fraction stuff to cancel out. So multiplying the right-hand side by x squared plus 2 squared. If we distribute this to the first term, well, we've got a first powered x squared plus 2 on bottom, so that'll cancel out one of those x squared plus 2's. So with this one, we've got our ax plus b, and then we've got 1 power of those x squared plus 2's left over. If we look at distributing to this second thing, both of these have a squared power on it, so both of those things are going to cancel out. So all we have left over here is the cx plus d. On the left-hand side, we've got our 8x cubed plus 13x. Now, if we take a look at this one, there is a little bit of foiling we need to do. So if we take ax times x squared, we get ax cubed. Taking ax times 2, we get 2ax. Taking b times x squared, we get bx squared. And taking b times 2, we get plus 2b. And then we still got our plus cx plus d on the end. Left-hand side, we've got 8x cubed plus 13x. Now we're going to look for things that are similar. So here we've got 8x cubed. As far as x cubes on the right-hand side, we've got ax cubed. So 8x cubed equals ax cubed. We're going to get rid of those x's by dividing both sides by x cubed. So this says a equals 8. If we're looking on the left-hand side, there are no x squared terms, so there are 0 x squareds. On the right-hand side, we've got bx squared, so 0x squared equals bx squared. Dividing both sides by x squared, we get b equals 0. For those plain x's, on the left-hand side, we've got 13x. On the right-hand side, we've got 2ax plus cx. So 2ax plus cx. We are going to divide everything by x to get rid of those things. So left-hand side is 13, right-hand side is 2a plus c. And then the last thing we have is our constants with no x's on them. On the left-hand side, there aren't any things that don't have x's on them, so we've got 0 on the left-hand side. On the right-hand side, we've got 2b plus d. We already know our a and b values, so we're going to work on figuring out our c and d values. So if we look at this c equation right here, it's got a in it, and we know that a is 8. So this equation says 13 equals 2 times 8 plus c. Well, 2 times 8 is 16. If we subtract 16 over, we get c equals negative 3. As far as this last equation, we know that our b value is 0, so we can plug that in there. So 0 equals 2 times 0 plus d. So this is saying that our d value is 0. Last thing we need to do is write out our fractions. So in that first fraction, our a value is 8x. Our b value is 0, so I'm not going to put that on the end. But this is over x squared plus 2. And then plus our c value, we just said was negative 3x, and our d value is 0. So again, I'm not going to put that on this fraction, but this is over x squared plus 2 squared. And here is our partial fraction decomposition. Here we go, last example. First thing we need to do is factor out the denominator. I see that all of these terms have x's in them, so I'm going to pull a GCF out. So then we get x times x squared minus 2x plus 1. There's more factoring that we can do with this x squared minus 2x plus 1. If we factor that out, on top we've still got 3x squared minus x plus 5. On bottom we've got x times. Factoring this out, we'd get x minus 1 and x minus 1. So this is a repeated linear factor. So I'm going to write that out as x times x minus 1 squared. And then our numerator is still 3x squared minus x plus 5. Now on the right-hand side, as we start breaking down these fractions, first one gets an x on the bottom. Since that's a plain x, we'll need a plain a on top. Plus, now we've got this repeated linear factor, so we're going to go with x minus 1 on bottom with just a first power on it. Since this is a first powered x, we're going to get a plain constant b on top. And then our second one is going to have the x minus 1 with a squared power on it. Again, first powered x, so we have a constant term on top. If we look at multiplying both sides by this denominator so that we no longer have all of these fractions in there, we're going to multiply by x times x minus 1 squared. On the right-hand side, we'll have to do that exact same thing, x times x minus 1 squared. If we distribute this to the first term, we'll have the a left over. The plain x's will cancel out, but we'll still have the x minus 1 squared left over. If we distribute to the second term, we'll have the b. The plain x will still be there, and one of those x minus 1s will cancel out, but one of them will still be there. And if we distribute to the third term, the c will still be there, and those x minus 1 squareds will cancel out, so we'll have the x left over. On the left-hand side of our equation, we've still got 3x squared minus x plus 5. I'm going to work on cleaning up the right-hand side because it's looking a little messy right now. This x minus 1 squared, remember we got that from x squared minus 2x plus 1. So really this is saying a times x squared minus 2x plus 1. Plus we've got this b times, I'm going to take this x and distribute it through our set of parentheses here. So we've got x squared minus x, and then we've got plus cx. More cleaning up to do with the distributive property. So taking a times x squared, we get ax squared. Taking a times negative 2x, we get negative 2 ax, and a times 1 is a. If we distribute this b, we get plus bx squared minus bx plus cx on the end, and left-hand side is still 3x squared minus x plus 5. Now we're looking for things that are similar, so 3x squared, ax squared, bx squared, so 3x squared equals ax squared plus bx squared, and I'm going to get rid of those x squareds, so we get 3 equals a plus b. As far as first powered x's, we've got negative x on the left-hand side. On the right-hand side, we've got negative 2ax minus bx plus cx. I'm going to get rid of those x's, so negative 1 equals negative 2a minus b plus c. And then our plain constants on the left-hand side, we've got 5. On the right-hand side, we've got a. So a is 5. If we work backwards, we could plug that 5 in for this a right here. So then our equation says 3 equals 5 plus b. So that must mean that b is negative 2. Plugging both of those things into this last equation on the right-hand side, we get negative 1 equals negative 2 times 5 minus negative 2 plus c. So cleaning this up, negative 1 equals negative 10 plus 2 plus c. So right-hand side, we get negative 8. If we add 8 to the other side, we get 7 as our c value. So now last thing, we have to write out this partial fraction decomposition with those a, b, and c values plugged in. So we get 5 over x plus negative 2 over x minus 1 plus 7 over x minus 1 squared. And there is our partial fraction decomposition. That's going to be it for this video. Please remember to fill out the Google form linked in the description down below. And thanks for watching.